Yeah, hi guys. So today we'll discuss about stack and queue. So how stack works, how queue works. So those two are part of collections. Okay. So already you have seen array list yesterday. Am I right? So everyone practiced array list.
Yes, sir.
Okay. So today we are going to see like how we have similar to array list. We have another data structure vector. Okay. So vector also it is same, but the internal implementation is a little different. Like in vector was released earlier in earlier versions of Java. Later array list also they released. So in vector it is a thread save actually. So little slow when compared to array list. So in real world like very less people use vector. Most of the people use array list. You understand? So coming to the, so we can create some vector and we can add some element, we can remove some elements. Okay, there is no difference between in methods for array list and vector. Okay, only a vector is synchronized. It was released earlier versions of Java. Okay. So that is about vector. So I will create some vector and I will we try to add some elements and try to remove it. And apart from that, we have two more important data structure. It is stack and queue. So earlier yesterday I said stack main. It's like a bucket and it's like some player putting it into the bucket. So if you try to take the plate from the bucket, if 10 plates you throw it into the bucket. So if you want to take one plate from the bucket, definitely you will take last plate, right? The plate you throw it at the last time, you will take that first time, right?
Yes, sir.
So for that is called stack. Okay, that is called stack. So that bucket operation, you just assume bucket. In that bucket, if you are throwing all the plates, so that is called stack. So the last one you are adding, that is the one you are taking out. So last in first out principle, you like generally we call it last in first out, LIFO. So stack works on which principle? LIFO, last in first out. Okay, and just you went to some theater and people will be on the queue. So if you entered into the queue and someone again came back behind you, so some four people are there in the queue. Who will be the coming first time out of the queue after entering? First person.
First one. Yes, sir.
Sorry. So first in, first out. So queue works with the principle of FIFO, first in, first out. You understand? Queue works with the principle of FIFO, first in, first out.
సార్ స్క్రీన్ ఏం కనిపించట్లేదు సార్.
No, I didn't start screen share yet. Just I'm explaining theory. Okay, just I'm explaining theory. Just you can understand. You can imagine queue, right? Like in a movie theater, you can imagine queue.
ఓకే ఓకే.
So who will come out like if three people entered into the queue, who will come out of the queue? First
First
person.
one, first person.
So first in, first out. So first in, first out. So this is principle actually. So in a queue, first in, first out principle. So in shortcut, we call that as FIFO, FIFO, first out. Okay. So we can see some images and you can understand. Okay.
Yes.
So we have different methods to add items into the stack, like how it is stack and queue difference, how to add element in stack, how to add element in queue, how to remove element in stack, how to remove element in queue, how to read top element in the stack, how to read head element in the queue. Okay, in queue we can say head and tail. In a stack you can say like top and bottom. Okay, we will see that. Let me share my screen. So you can see this here. We are adding an element to the stack. Okay, stack mean one side close, one side open. You understand? So you can imagine like a normal bucket. Okay, so bottom it is closed, top it is open, right? So top of stack mean we are adding one element. So this area means top of stack. As of now, top is empty. So one element you are inserting here. So now stack is having element A. Now in this stack already element A is there. Now you are inserting element B. So now stack is having element A and B. Okay. Now again you added element C. Now stack is having element A, B, C. Okay. So the elements only we call that as data he is mentioning. Okay. So now if we want to remove element from the stack, okay, which element will be removed first? C, B or A?
C.
Only top element C. Okay. Top element will be removed.
Yes, sir.
So now after removing the stack is having A and B. Now again he is removing B. Okay. Now we are having A. Now again he is removing element A. Now stack is empty. Okay. So this is, you can see here, a stack holds elements in last in first out fashion. That means last in, the element which is coming last will be removed first. You understand? The element coming last, C came here at the last position. That C only removed first here. That is the reason here we call this principle as last in, first out. The element coming last will be going out at the first place. Okay. So last in, first out. This is the principle actually. Okay. This is stack. Okay. So take one screenshot for this and save it. Okay, done. Yeah.
Yes, sir.
Now we go further. So stackman, as I said, it is a one side close. It's like a bucket. You can add elements, you can remove elements. So you
Yes,
can.
sir.
So this principle is called last in, first out. In shortcut, we can call LIFO. 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 Okay. And come to Q now. Q. QU. P. Now, see, they mentioned here Q mean it's like a front rear. Okay. We add at the rear, we delete from the front. Okay. And also you can call head and tail. Okay. We insert here at the tail and we remove at the head, like at the head position. Okay. We can also call head and tail, or else you can call front or rear. Yeah, see here, this is two side open. Okay, this is two side open. Stack mean it is one side open. Q mean it is two side open. So one side elements will be entered and the other direction elements will be go out. Okay, so generally we call this as head. One direction we take it as head, and other direction we take it as like a tail. Okay, so this is front end, we call it as head, and back end we call it as tail, and data will be entering into the queue at the tail side. Okay, so now we entered one data 1 here. Okay, now again we entered another data 2 here in the queue, And again we have entered another data 3. So this queue is having data 1, data 2, and data 3. And now again he mentioned here, elements enter queue at back and leave from the front, and this sentence is clear. And now if we want to remove an element, which element will be removed first? The element the entered first time, so data 1 will be removed. And again if we remove element, again the second element, and again third element will be removed. So first in, first out, the element whichever the element coming first time into the queue will be removed first time. Okay, see, data 1 entered first and data 1 only removed from the queue first. So first in, first out. Okay, so this is the what principle it is? First in, first out principle. If someone is asking on what principle queue is working, you should say FIFO, first in, first out. Here it is. Here in stack, last in, first out. LIFO, stack is LIFO, last in, first out. Queue mean FIFO, first in, first out. Okay. Okay, so I think you are clear with this queue operation, right? So take a screenshot for this.
Yes.
Okay, this will be done.
Yes, sir.
Okay. Just I created one package. So I'll create one class like yes, stack example. Okay. Now I'll add one main method, finish. Okay. Now before that I'll cover vector ones. Okay. Vector new class, vector example, add main method, finish. And also I'll create one class for stack and queue also, queue example. Okay. And now finish. And also I'll create one example for a set example. Also I'll create one class for a map. Okay. Finish. And also I'll create one class for a linked list. And also as of now I think today these are enough. Okay, so I'll go for vector. Okay, so vector. So command, just like a array list, create one object for vector. VEC your vector of type integer, something, anything is fine. Some list equal to new vector import java.util package, and now add elements into the vector. List dot add something like 23. List dot add 25. List dot add something like 78. Elements you can add any element. It's not like order, right? So add something like 90. So I have added some 4 elements into the vector. It's similar to array list. There is no difference actually while utilizing vector. Vector is little slow, array list is little fast. Why? Because vector is thread safe actually. Okay. Now how to like read element, like just print using sysout list. I'm printing vector. Similar to array list, vector also a continuous memory allocation only while storing the elements. Only it is thread safe. That's all. Thread. Okay. Like while covering multi-threading, you can understand what is thread safe. If you use synchronized keyboard, you cannot use that method parallelly with the. If you make one method as synchronized, one by like multiple resources cannot use that method parallelly. Okay, so that is synchronization actually. That concept we can cover while when I explain multi-threading. Okay, so just is if someone is asking you, you should say array list and vector are it is similar. Only array list is not thread safe. Vector is a thread safe. Array list is little faster when compared to vector. That two sentences are enough if someone is asking you difference between array list and vector. Okay, so now we are able to see 23, 25, 78, and 90, right? So you added elements. Okay, and how to remove element? List dot add, sorry, list dot remove some 24, sorry, 23. Just I call remove method syso list run as Java application. So now you can see what is the error.
I think
Yeah.
index.
Yeah, we have to provide index, not a value. Okay, so give index as 1. So we can remove 25. So now we removed 25. Since similar to array list, here we should give index only for removing also. Okay, now syso list dot, like if I want to read with index, get method is there. If I want to read 0th index value, list dot get of 0. Now print it. Java application. Yeah. So now I have printed 23 at using get method. Similar to that, like if I want to identify whether a particular element is present or not, we have contains method. List dot contains. We need to pass object 78. Okay, if 78 is present in the list, it will throw true, or else it will give you the false. Okay, understand? 78 is there in this list. 78 is there in this list, so it printed true. Okay, it printed true. If you don't want to print it directly, you can pass that value to boolean, because true and false are boolean, right? Status equal to list dot contains. Now you can print that status.
Print status.
Okay, so you can, if you want to read that boolean status directly, you can do like this. Okay, run as the application. So now what way operations I have done in vector, similar to array list I have done. Okay, so if I want to use for each loop, same here also, for int or integer, anything is fine. Integer, some integer obj. Okay, colon. What is my list here? List. And now print obj SYSO obj. That's all right. Run as the application. So we have printed our list 23, 78, and 90. If we want to print one line like in the single line, remove that ln method. Give only print instead of ln, and here add some space, or else all the values will come into the one by in a single line. You can see that here. So my number is 23, 78, 90. Here see 23 is there, 78 is there, 98, 90 is there. So how can I add space here? Just add here plus some empty space. Okay. So now every time what will happen? It will, and again next time anyway space is there and number and space. So number and space, number and space. So you can see some space actually. For last element, space will be added. That is fine, right? Here space will be added, but that is not an issue, right? You can see elements like this. You have a trim function actually. So at you can remove empty space using trim function, trim. Okay, whenever you can use that. Okay, now this advanced for loop, everyone clear, right? Anyone having doubt in this advanced for loop?
Clear.
Yeah, clear. Okay, now
Can you please explain once advanced for loop?
nothing actually, like you need to take some column, okay, and right side you need to mention your list, okay, like that list having all the items. So this list is having some three items as of now at the end. That three, since the list is having three items, that size is 3. Okay, so since the size is 3, this for loop also will be running 3 times. Okay, this for loop will be executing 3 times. Now for each iteration, what will happen? Here it is having 3 elements. Each element it will pass to left side variable. Okay, each element pass to left side variable. First iteration it will pass first value. In second iteration it will pass second value. Third iteration it will pass third value. So for each iteration you will get new value into this variable. That value I am printing here. Okay, since it is a variable, I need to mention. So I give an integer obj. Just I am mentioning this obj is integer variable. Okay. Side you need to declare variable to hold data. Right side you need to mention collection. Okay. And you need to print your variable. So each iteration your variable value will be changed. So you can see values like this. Like first time in first iteration 23 is coming into your obj. So 23 and space I have printed here, 23 and some space. And second iteration is coming from that list to obj. Now I'm printing obj again. Now what happened? 78 and space is printed. And now third iteration from this list 90 is coming to obj. Now obj is having 90 now. So now obj and space is printing here. Okay, you are clear, Gautam?
Clear.
Yeah. Fine. So when you compare, there is no difference between method have written for array list and vector. Methods are same. Only the creating the object creation is different. That's all. Okay. Now, anyone is having doubt in vector? Vector is also similar to array list. Array list also vector also similar to array list. It is also elements will be allocated in a continuous memory allocation. So that is the reason we access this vector also with index. Pratyusha, okay, can you please mute your laptop? Yeah. So similar to array list, here also we can access with the index while removing. Okay, that's all. Now you people practice this one. I'll share it. Okay, vector program I have shared. Now go for stack. stack or stack you can give. Import that stack class from java.util. Now, as you aware, side close, one side open, right? So it is last in, first out. Now, to insert an element, we have method like push method, push. To read to remove element, we have pop method, pop. That means it remove top element. Okay, it return it, and also it will remove. Okay, that we will see here. STFCK stack dot to add element, we have method. Okay, some 20 are given. Okay, 20 are pushed. Now again I'm pushing stack dot push 21. Now stack dot push 22. Now stack dot push 4 elements I pushed into the stack. Now SO stack. Okay. Run as Java application. So you can see all elements. Okay, 20, 21, 22, 23. Now the stack is having all 4 elements. If I want to like remove the top element, okay, just call stack stack dot pop.
Pop.
So which element is added last? 23 only. Am I right? Which element we push last? 23. So as I said, the last element only should be removed. The stack is LIFO, right? So 23 should be removed as of now, as that is my expectation. Right? So run it. So see here, is 23 removed or not? Right? So that means the element you entered last into the, so just assume stack in a bucket. So you are throwing that elements into the bucket. So which element added last? 23. So while removing also, for that, so while removing also, we are removing last element. Okay. So generally remove that element and okay. So if you want to catch it, the int some number equal to, if you call, okay, if you call that, you can catch that number also. Okay, just I'm printing that remove number only here. You see, run as Java application. See here what happened. Just I called stack.pop, it removed data. Okay, I have to print also, right, entire stack. So stack now run as Java application. So what happened now? Just I called stack.pop here. It removed 23 and also it returns 23. It returns and also it removed from the stack. So that my number is having that 23. So same that number I printed here. So you can see the 23 here. Now I am again printing my stack. So what is happening? I can see updated list, the 23 got removed from my bucket. So only 20, 21, 22 is present. 20, 21, 22 present in my bucket. Okay, this is stack. And now SYSO stack dot peak. Okay, stack dot peak. So what is this peak method? It will not remove the top element. Return it. That's all. Okay. So now again you do it. SYSO stack run as. So what happened? So what is my top element now after removing 23? So when I call stack.peak, it returns top element, but it will not remove. So again, when I print update 22 also there. Okay, what is the difference between pop and peak? pop method remove the top element. Pop method, peek method only return the top element. It will not remove. Okay. Pop element returns and remove both. It returns and remove both. Peek method only return the element, not remove. Okay. Only it return top element. That's all. So here this is my current list. My top element is 22. When I call peek method, 22 was written. When I call peek method here, 22 was written. Okay. So these are the basic operations. Okay. Push, pop, and peek. And SYSO. And what we can do. And now SYS. Now what I'm doing? 3 elements are there. Now what I'm doing? I'm popping again and again. Now 22 is there. 22 will be removed. Now 2 elements are there. Now 21 is removed. Now again I'm printing SYSO stack. My updated, I applied pop 2 times. So again 22 and 21 removed. Now I have only 20 in my stack. So now again I will remove. Control C. Okay. Now again I will print it. Run as Java application. So my stack is empty now. So if stack is empty and if you try to remove some element, you will get empty stack exception. Okay. Now again copy. Now you are trying to remove something from empty bucket. So you will get some exception. Okay. You cannot, like, that statement will not execute now. The last statement, run as the application. So what exception? Empty stack exception. Okay. You cannot remove any element from empty stack. Okay. If you want to remove something element, the stack should have some elements. You cannot apply pop method on empty stack, or else you'll get empty stack exception, as you see here. Okay. So these are the major options, and you can explore more just by clicking here. Okay. stack dot add is there. Okay. Add int index, some index it is showing, capacity, and clear, clone method to copy, contains method to verify element is present or not in that stack. Okay. Copy into, like, element at, like, for particular index it will return the element. Empty. Okay. So these all are methods we have. Okay. Get index. Okay. Like, you can get some element at a specified index. Okay. Because stack and you also internally use array list. Okay. So you can use some methods like array list, but for a stack data structure, that is the structure actually. So that push and pop methods added additionally, because stack is one kind of data structure. On top of array list, they developed stack. You understand? And queue also one kind of data structure. On top of array list, they developed queue. So you have some common methods between array list and stack. So you can utilize all the methods present in this here. Okay. Remove also there here. Like, you can remove element at specified index. Okay. Like, add element. Okay. If you are using here add and remove, it is like a normal array list. Okay. If you are using push and pop, then stack functionality will apply. If you created stack object and again you are using add and remove methods, mean you are not utilizing stack data structure functionality like push and pop. Okay. Stack means that is a one data structure. You are pushing something and popping something. Okay. You cannot say like, this is also working like a array list. It works like array list also. Why? Because stack developed on top of array list. You understand? Yeah. Now we go for so now I have explained stack architecture. stack data structure. So you can explore more, okay, by googling it. Okay, now let me share this program. Okay, now we go for queue. Similar to stack, create one object for queue. QUE, take some integer. Queue object QUE. Just imported this queue from util package, and here QUE dot add method add element at the like tail actually. Okay, add something 20. Now q dot add 21, q dot add 22. Now I have added 3 items into the queue. Okay, now okay, I'll add one more element. Okay, I have added 4 elements into the queue. Let's see what is the error. Cannot instantiate type queue. So we have something like queue is interface. I think we have some classes for queue. Okay, like priority queue, like that. 1 second. Okay, so we have priority queue and DQ. So as of now, use priority queue. Okay, so I will check it and let you know what is like a priority queue it created. We will see that as of now queue functionality is same. It's a head and tail. Okay, so priority queue is a class. Priority queue is a class. It implemented queue interface. Okay, so you can assign child class object to parent class reference variable. Okay, now what it is showing to you something. Okay, again it is okay. Now queue is there, SYSO run as Java application. So in my queue it is having 20, 21, 22, 23. So which one which is the element I added first? So 20. So 20 added coming into the queue, and 21 also coming into the queue. So 22 and last element 23. So which element and is present at the head now? Someone tell me which element is there at the head position?
20.
20, exactly. Which element
sir.
is there at the tail position?
23.
Yeah, exactly. If I remove some element, which element will be removed? Head position.
20. First one 20 will be removed.
Exactly. Okay.
First
So
in,
now,
first out.
correct. So now q dot q dot poll you have to call here poll. Okay. Now SYSO, let's see which one is getting removed. Our expectation is 20, right? QVEV. Okay. Okay. So it removed element at the head position. 20 is at the head position now. So after applying pole method, it removed element at the head position. So now updated list is 21, 23, and 22. Understand?
Yes.
Yeah. Now, again, what happened? Like this pole method. See here. That pole method, if it is add, if it is removing element, it returns true. If it is not removing element, it returns false actually. Okay. So if I give this here, okay, see here. Okay, so it returns actually. We have another one. Apart from pole, we have so just I am printing peak element. Okay, just I am calling peak. So it will not remove that the head element. Just it will print it. Okay, pole mean it remove head element. Peak mean it will not remove. The peak functionality is same in stack and queue. Okay, in stack also peak mean it return. It will it not it had it hadn't return it hadn't removed the top element even in the stack, right? Here also it will not remove. So give again q. See now, run as. So what is my current updated list after removing like after applying poll? 20 removed. Now updated list is 21, 23, 22. Now what I have done here, I am calling q dot peak in this isort. Q dot peak means it returns the element present at the head. It will not remove, just it return 21. And again, if I print updated list, again it was printing 21. That means you understand the difference, right? Pole mean it returns the returns and also removes the head element. Okay, but peak mean it only returns the head element, it will not remove. Understand? Pole mean returns also removes head element. Okay. Peak mean it only returns head element, it will not remove. Okay, so this is about some queue functionality. Yeah, give me a minute, 1 second. So, and also we have multiple methods, like different methods. You can verify all the methods, like just give a dot here for that your object. You can try using all these methods by Googling it. You can identify each method how it works. Okay, size method, it will return you size. Remove method, it will remove object at specified, like whatever the object you give, it will remove. Okay, uh, and peak poll I explained. Offer method also add element into the queue, but it returns true or false. Okay, it returns true or false. Now is empty, it will tell you if the list is empty or not. Okay, so you can try contains, it will tell you if particular element is present or not. So I told you basic important operations in the queue. You can utilize, okay, all the available methods. Okay, now see here, we can also use offer. So you can see here, my list is having 24 now. Okay, so add method returns, after adding it returns that element, but offer method, it returns only true or false actually after adding element. Both are methods to add element. Understand? Now, this is about offer method. Yeah, that's all actually. Okay, so this is also same, like using advanced for loop, you can print this queue. I think you people can try. Okay, so anyone is having doubt in this queue? Everyone clear, or anyone has any doubt? If anyone is having doubt, I will repeat it.
Once again, repeat, sir.
What doubt you have?
Sir,
Where, like, in which point you have doubt? Like, what is your doubt exactly in queue?
removes head element, sir.
Removes head element. Yeah, here head. Which is the head element here in this queue? Which one you added first? Like you went to the movie, you will be standing in the line. Behind you, some 4 people are there. Okay. So
Okay,
you
sir.
entered in the queue first time. So who is head now? At head position, there is a head and tail. Who is there
Okay.
at head position? You only, right?
21, sir. First in index.
See here, there is a queue. There is a line. Okay. Now there is a line. In that 20 added first. Okay. And he is at head position. And again 21 added behind him. And now 22 again added in the queue. And last person added in the queue 24. Okay. That means they are buying movie tickets. They are in the line. Okay. That is queue, right? We call it as queue, stand in queue, right?
Okay.
So who is at the head position? 20. I
20.
mean, who entered first? Who will buy the ticket first? 20.
20.
Who entered the last 24. So this is head position. This is style position. That's what you clear now.
Okay, sir.
Now, if you, there is a method called poll. If you call this poll method, it remove element at the head position, and also it return to you if you call it. Okay. So it remove that element. Here I called poll. So now I created a queue and printed. Now my queue is having 20, 21, 22, 23, 24. Now I called poll method. What it will do? Poll method, it remove element at the head
20.
position. Now I'm printing again. I'm printing again the queue. Now after removing the element at head position element is 20. Now updated list is 21, 20, 23 remaining elements. Understand?
Yes, sir.
Yeah. Now what does peak? Peak mean it will not remove head element. It only return head element. Okay. It only it's like reading head element. We are not removing. Okay. Peak mean. So I called peak method. What it printed? So as of now, what is my head element here?
20, sir. Head element.
21.
21 Aparna. I highlighted here, right? This 21, right?
Remove that 20, sir. First again, remove that head element 20.
Now after that, now this is updated list. This is updated list. Like we
After
removed, right?
removing the 20.
Yeah, we removed
After
20.
Yes, yes, sir.
This is updated list list. Okay,
Okay.
now 20 is not there. So what is my head position now? 21.
21.
So if I call peak method, it returns returns head element actually. So when I call peak method here, just it printed 21 here.
Yes, sir.
And now when I print again the queue, the 21 also you can see in my updated queue, because we are not removing with peak method, just it only returns. Okay. So that is the difference between pole and peak. Pole mean it returns, it remove head element. Okay. Peak mean it only returns, it will not remove. Okay. So you practice it, and also you have to Google it. Okay.
Okay.
Yeah. Now you are clear.
Okay, sir.
Yeah. Gautam, you are clear.
Clear.
Okay. Raju, you are clear.
Yeah, clear, sir.
Yeah. So is anyone having doubt? Let me know. We can discuss. Okay. Yeah. Then apart from that stack and queue, you will learn these programs by practicing only. Okay. Just in class you can understand, but not 100%. You can, like, you cannot type without practicing, right? So you have to practice again after the class. Yeah. Tell me. Tell me, Satya. Ravteja.
Prasadam and Ravteja.
Tell me. Tell me. Tell me, Ravteja. Okay, that's fine. So now stack vector is clear, stack is clear, queue is clear. Okay, you practice it, then only you will understand more. Okay, now queue I given, stack I given, vector I given, all three I given to you. Now linked list. Okay, not linked list, certain map. I think you guys practice today about vector, stack, and queue. Tomorrow I'll cover linked list, set, and map. Okay. Okay, guys. Yeah. Bye. Like you guys saved these three programs, right? Already I shared.
Yeah, Prasad.
Yeah. Tell me when.
Can I share my screen?
Sorry.
Screen share చేస్తాను. నా ప్రాక్టీస్ చేశాను కదా కొన్ని డౌట్స్ నాకు.
Yeah. Share.